Welcome everybody. My name is Jan-Peter Krämer. I'm from RWTH Aachen University, and I want to talk about how we can use runtime traces to improve documentation and unit test authoring in dynamic languages. I've worked on this in collaboration with Brandt from Adobe Research and my advisor Jan Borchers. So we know from related work that documentation and for dynamic languages that includes type annotations and unit tests are helpful to comprehend code and to prevent introducing errors after making changes. But we also know that these documents are often missing from the code or are not up to date. And we believe that part of this problem is in the interface design of current development tools and, as we've heard in the first talk, in the effort required to create these documents. So let's, as an example, look at one single method. It takes a parameter, it uses JavaScript's parseInt function to convert it to a number and then increments it by 2. And this method is actually documented, but the documentation claims it would only accept the number parameter, whereas actually it also works with a string. So it's likely that someone inserted this call to parseInt and then forgot to update the documentation, and that's super common because there's no semantic connection in the interface anywhere between the documentation and the method. And the same is actually true for unit tests. So if we wanted to find the tests for this method, we would zoom all the way out and have to know that the unit tests are actually collected in a separate file somewhere else. So we set out and asked ourselves how we can do better and how we can design an interaction that encourages developers to author more documentation and unit tests. And to answer this question, we looked at how developers currently work. And we've seen in plenty of previous studies that developers switch between editing and testing their code in very short cycles. And for them, this has the benefit of having a very small scope of source code in their head to understand mentally while debugging. But having a small scope of code that you currently understand is probably also pretty good to write documentation and unit tests about it. So our idea is to integrate this documentation and unit test authoring into the edit, test, edit cycle. But of course, if we insert something else into this cycle, we have to make sure that it's pretty quick and easy to do and allows for a fluid interaction. And to achieve this, we propose to use runtime information from the manual executions that occur during the test phase. Using this runtime information, however, can have 4 potential problems. First of all, developers will typically not exercise all the path through the code, so the information can be incomplete. The last manual execution might have happened a while ago, then the information becomes outdated. Developers might execute the code while it's in an incorrect state. This means that the information we get for documentation and unit tests is also incorrect. And as we've also heard before in the session, the software is likely to change, and that makes the information impermanent. So let me show you an overview of the prototype we came up with. This is the same method you have seen before. The documentation is now contained in a separate documentation editor that is embedded into the source code. And the unit tests also have their separate editor on the right side of the screen. And all of this is integrated in our Vesta plugin for the brackets editor. Let me walk you through the interaction with this tool. So here's again the function you have seen plenty of times at the point in time before we actually inserted this call to parseInt. And currently the documentation is not yet there, and we can just execute the code, and Vesta will collect the runtime trace and automatically insert all the information it found into the empty documentation to get us started. In this case, that's the type information for the parameter and the return type. As a developer, I now only need to go ahead and add custom explanations to the parameter and the function. And this is possible using standard text editor interactions, moving a cursor, and using a standard documentation markup language, and Vesta switches between both representations as needed. And this interaction actually already takes care of the first 2 problems I've mentioned. The developer probably will execute the method he's currently working on, so it doesn't really matter if other methods are not covered. And the developer is tempted to work with the information immediately after it came in, so it's also likely not yet outdated. After a while, we executed our application again, and Vesta recognized that in this execution, we actually got a call to the method that passed a string parameter and not a number. And in theory, this can have 2 reasons. Either we introduced a bug somewhere where we used the method, then we can navigate to the call side and fix the error there. This is how we deal with incorrect information in Vesta. But in this case, the change is actually intentional because we inserted the call to parseInt that you have seen before. So our method does now accept both strings and numbers, and we can use Vesta to update the documentation accordingly. And this is how we deal with impermanent information in the documentation component. So the unit test component is separate. You see it in this screenshot. It works slightly different to the documentation component in that Vesta never automatically inserts a unit test. Instead, we provide templates for the creation of unit tests that use runtime information. So the first option is to actually create a unit test that reruns a recorded method execution and verifies that the result doesn't change. And the second template actually allows you to create unit tests for common edge cases depending on the type of parameters that are specified in the documentation component. The interesting question is, of course, does Vesta now really encourage developers to author more and better documentation and unit tests? And to find that out, we invited 14 developers to implement a parser that should be accessible through a web-based API, so a fairly complex coding task that should be completed in 6 hours. And we assigned developers to one of two conditions, either using our tool or using the brackets editor without any extensions. Let's first look at documentation. In terms of accuracy, and by accuracy we mean is all the type information that is recorded in the documentation actually correct, Vesta improved the situation significantly. If you think about it, this is actually to be expected. Most of the type information will be automatically generated by Vesta, and there's only if developers manually edit this information, they will have an option to make it incorrect. More interestingly, if we look at completeness, and completeness refers to did developers actually add a manual description of parameters and functions, we also see that Vesta improves the situation quite a bit. And this is interesting because it means that developers were really encouraged to put more effort into creating these documents. When we ask the same question for unit tests, we see that the average number of unit tests created throughout the trial went up significantly when using Vesta. However, once I reveal the axis, you will probably figure out that the number of unit tests created is pretty low in both conditions, so we can't really call that a success. But the question is, why did the documentation editor work and the unit test editor did provide these mediocre results? And we think the real difference is the feature you see here. The automatic type checks that are performed by Vesta to keep the documentation accurate and up to date are actually useful in a number of scenarios besides writing documentation. Developers use this to spot errors, to understand how libraries they use work, which types they return. And this means that the documentation component provided more near-term value for a developer than the unit test component did. And we believe this is what caused the one component to work good and the other one to provide results that were not really overly better than before. So to sum up, we presented Vesta. Vesta uses runtime information from the manual executions developers perform in the test phase to integrate the authoring of documentation and unit tests into the edit test edit cycle. And in analyzing this interaction design idea, we found that to encourage these authoring processes, the tools need to provide additional near-term value that make the whole process more valuable at the time developers are actually writing code. And with that, I want to conclude my talk, and I'm happy to answer your questions.
Thank you. I think this looks really valuable. I was just a little confused about the unit test part. You said it was separate, and perhaps that contributes to why it wasn't used as well. And if you could explain, what happens if a unit test fails? What's the process for then modifying the code? And
yeah, that's a great question. There's the editors are separate in the way that there is a separate editor in which you maintain the documentation and the unit test. There is an option for an automatic link. By default, we set it up in a way that you get one set of unit tests, a collection of unit tests per method. And you can use this to structure your unit tests, and then Vesta will automatically show you this collection while you navigate through your source code, so you will always see the appropriate unit tests on the screen. There's also the option to view the backlink. So after you ran the unit tests, it will again do a runtime trace in the background and see which tests are actually calling into this method, showing you all the tests that are testing this. So this is regarding the backlink. There's some interaction. Just the editors, the parts where you edit the unit test information and the documentation are separate. The second question, you can execute the tests, and you will, well, the first thing you will see is again runtime information. So you will see which methods the test called, even down the call stack. So you get this inspection, and of course you will see the test result, and you can navigate to erroneous call sites. But we really focused on the authoring process of creating them, and less on creating a test, a tool to run all the tests, because there's plenty of work where this is appropriate, even going into the direction of doing continuous testing, which I think would be a very valuable addition to such a tool, because it gives you way more immediate benefit even for the unit test. Does that answer your question?
Thank you. Hi, Ken Van, University of Edinburgh. I'm curious why you decided to use runtime. I mean, this is clearly you just made a decision here, but why use runtime information as opposed to things like static analysis that might have created something more structured and wouldn't have run into some of these weird cases, like the example with the string?
That's a good question. I think the main reason here is that we focus on dynamic languages, which are harder to analyze statically, just because they leave more degrees of freedom open in the way they're written. There is by design no type information in dynamic languages, because it's supposed to be changing. For example, through outside APIs, there is deliberately call site polymorphism in dynamic languages that you might or might not have in other languages. There's things like eval and so on that give these languages more power in a way, but they also make static analysis harder. There is some pretty interesting work on how to tackle some of these technical challenges of applying static analysis to dynamic languages, which I would absolutely appreciate to integrate here, but I think the selection mechanism of runtime information is appropriate for dynamic languages, and it automatically gives you, because the developer does the execution himself, it provides a way of filtering out of the information what the developer is currently interested in trying out.
Thank you.
Hi, I'm Nan Chen from University of Washington. Just a quick question about, like, have you contrasted use of the novice programmer versus the expert programmer? Because sometimes documentation hasn't been done just mostly because the like documentation practices is not just part of their workflow. So how does this tool can help like the novice programmers to do something about that?
Well, that's a good idea. We made sure that we have a pretty homogeneous group of developers. All of them are students. We made an entry test to make sure that they know their ways in JavaScript and have done some work with it. I absolutely do think that this is more valuable in a not so strict programming context. So once you're in a professional team where you have coding guidelines and code reviews that make sure that all of this is in place, your need for such a tool probably diminishes from a process standpoint. Mm-hmm. It might still, even for those developers, make the authoring quicker in a way, because it gets you bootstrapped and it reminds you more constantly than probably working towards a coding guideline would.
Okay, thank you.
Hey, Saigar Rajula from the University of Michigan. So you sort of mentioned that some use cases are missed because it's all dependent on developers sort of thinking about whatever they want to test for their test cases. Have you thought about how Vesta could integrate the use of fuzzers, for example, like black box fuzzing or white box fuzzing in terms of getting information from the runtime and then sort of creating test cases automatically?
Yeah, I've seen some pretty impressive work on how to generate test case suggestions. And admittedly, the analysis process we employ to prototype our interaction design is not like out of the world complicated. It's actually by design fairly easy. I do think that there's value into exploring these more sophisticated algorithms for test case generation and to incorporate this. The only fear I would have is that the connection between where this information comes from for the developer also becomes more fuzzy. Currently, it's very easy to relate to which information is on screen because it's information you in some way just inputted into the system manually. If you do a black box fuzzy test where you try to guess inputs and try to exercise different paths through the source code automatically, this might be harder to assess for the developer using this information.